Day 24, page 654, problem number 19. Here's a great problem. I gave you the geometry with the diagram here. The two red locations, two red charges here are what we're starting with. The blue charge is far, far away when the problem starts, and it'll land far away, but now it's near at the 0, 4 coordinate, all in meters. Nice, standard units. This is basically an energy problem. We figure out how much energy the system has relative to this negative 10 microcoulomb charge. For example, these are point charges. This is not a vector problem, it's an energy problem, so we're not going to be drawing any arrows. But the key equation is electric potential energy, U sub E, equals K Q1 Q2 over R, not R squared. You do these in pairs. For example, if I find the potential energy relative to the negative 10 and the positive 10, right now as is, when they're in this particular position, which will be here, 9 times 10 to the 9th times 10 micros, 10 times 10 negative 6th, times the other negative 10, the blue charge that we moved in there. I've drawn it in blue. But the negative is important, 10 micro, divided by the 4 meters. If you do the computation here, I'm just going to call that U sub 1. It's due to electrical interaction. U sub 1 is 0.225 joules. That's an important number. I'll circle it. It's not my answer. I'm going to keep track of that. And then U sub 2 will be 9, the other pair, not the 10 and 25, not the positive 10 and 25. That was energy already in the system. I'm trying to figure out the additional energy in the system, or that has left the system. Let's see here. Times the negative 10 that we brought in, micro, times the 25, what, negative 25, micro, divided by, there's separation distance, and if you look at the geometry here, it's like the hypotenuse of a triangle, and remembering your 3, 4, 5 triangles, that's 5 meters. So that's your 5 meters, and you calculate U sub 2, potential energy, electrical potential energy is, well, it's 0.450 joules, and that's positive. I forgot to mention in the first problem, I left it off. In the first case, that was a negative potential energy. So we have these two values. That was important up there, the negative 0.225. Let's just talk about the signs once. The second one's a little bit easier to deal with. Bottom line, at an infinite distance, when the negative 10 microcoulomb charge is at an infinite distance, its energy relative to either one of the 2 points is 0. But as you bring it close, it gains energy relative to the negative 25 because there'll be more force to try to push them apart. So you're gaining energy relative to the negative 25. In other words, you gained 0.45 joules of energy, but you, in a sense, lost energy. It's lost potential energy as you bring it close to the 10 microcoulomb charge. But the net is you add U sub 1 and U sub 2. So you just add those together. We can do that in our head. So U sub total, the total energy that the system gained, all right, I could just write delta U is a gain of 0.225 joules. So that must be the work done. The work that was done to create that amount of energy is that amount of energy, 0.225 joules, work energy theorem. So there's my answer right there. The work done is 0.225 joules. Congratulations.